Very good. We're going to talk about operations between matrices. As you know, matrices are some mathematical objects. So we expect to add, subtract, and also multiply them some way, somehow. For multiplication, we have two types of multiplications: scalar multiplication and also multiplication between two matrices or product of two matrices. So let us first learn how to add matrices. Let the very first matrix, represented by its entries A sub ij, and it's a matrix with m rows and columns, and you have another matrix B sub ij with exactly the same number of rows and the exact number of columns. If you have these two matrices, you're allowed to add them together. Then we can add them. To add these two matrices, it's very easy. You are actually going to add the entries, corresponding entries together by adding the corresponding entries. What do I mean by that? Let's take a look at the example from the note. Suppose I ask you to add these matrices. In example A, you have a square matrix, -1, 2, 0, and 1. And the second matrix, another square matrix, 1, 3, -1, and 2. So of course you have a 2 by 2 matrix here. You have a 2 by 2 matrix here. It means that you're allowed to continue. It is equal to corresponding entries A sub 1 and 1. The very first element in the first row is -1, will be added to the very first element on the first row of the second matrix. We're going to add -1 and 1, which becomes 0. Then you're going to add 2 and 3, which is 5. Then you move on to the second row. 0 plus -1 gives you -1, and 1 plus 2 is 3. And as you can see, you have a 2 by 2 matrix as well. This is our new matrix. In part B, you have matrix with elements, entries 0, 1, -2, and then 1, 2, and 3. And the second matrix is 0, 0. All entries in your matrix are 0. We're going to check to see if we can add these two together or not. So you have a 2 rows by 3 columns, the same for the second matrix. So I'm allowed to add these elements, entries, corresponding entries, and create a new matrix. So I have 0 plus 0, 0, 1 plus 0, 1, -2 plus 0, -2. Then you have 1 plus 0, which is 1, 2 plus 0, which is 2, and 3 plus 0, which is 3. So obviously, you got the exact same, note that you got the exact same matrix back. So this is just a matrix that has no effect on the original matrix. You got the same matrix back. Remember, in pure algebra, you had a neutral element that they called 0. Any number plus 0 gives you that number back. So this matrix in this operation, in this system, also act as a neutral element. Any matrix added to 0, going to be the same matrix back. So let's take a look at two column matrices. I have the very first column matrix, 1, -3, -2. And the second one is -1, 3, and 2. These are column matrices. You only have one column. You have 1, 2, 3 rows and one column. Both of them have the exact same size, so you can create a new matrix by adding them. 1 minus 1, 0, negative 3, plus 3, 0, and negative 2 plus 2 gives you 0. So you get another 3 by 1 matrix, which happens to have all zeros on its entries. Now here's a question. Can we add the following matrices? Here we have matrix 2, 4, 1, 0, 0, negative 1. As you can see, it's a 2-row, 3-column matrix, 2 by 3. I try to add this guy to a square matrix. Well, 0, 1, negative 1, and 3. So this is a 2 by 2 matrix. So note that since they are not of the same size, 2 and 3 are not equal to each other, you are not allowed to add these together. It is not defined. Make sure that they have the exact same size.